Hello and welcome to the Protection in Electrical Power Systems. And today's lecture is about the electrical power system, its faults and the security of supply. First, let's talk about the electrical power system and the fault that may occur in such a system. The electrical power system, as we can see here, is made up of different layers and they are rated according to their nominal voltage. The top layer is the transmission layer, that is usually 750 kV, 400 kV. After that, below, under it, we have the sub-transmission layer, which is something like 110 or 132 kV. Below it, it is the medium voltage level, and then we have the low voltage level. That is where we, as consumers, take our electricity from. And in all these levels, faults may occur. So let's start with, from my point of view, the most severe one. That is the 400 kV busbar fault. Such a fault may occur and it causes not only a busbar to be tripped, but all the infeeding and outgoing transmission lines, and they afflict vast areas which are supplied with electricity. Also, faults can occur on 400 kV lines, but that is not so severe to the electrical power system because these lines usually come in pairs of two. So if one line trips out, the other one line will take over the load and the supply and the transport of electrical power is not afflicted in a very severe way. The next type of fault occurs in the transformers, which are between these voltage levels, for example here between the transmission and the distribution level. If such a transformer fails, again we have redundant structure. As you can see, there are two of these transformers in use, and the transport of electricity from the high voltage levels to the consumer voltage levels is not severely impaired. Also, we can have busbar faults, we can have line faults, and we can again have faults in the transformers between medium voltage and low voltage. These transformers usually are located in ring main units, and since the low voltage system usually is made up as radial networks, and such a fault trips the consumer's electricity supply. Of course, it should be mentioned that also faults in users' premises are to be observed. So, of course, there can be faults in generators on high voltage and extra high voltage generators, medium voltage generators, low voltage generators or low voltage infeeds. They are not so severe to the power system because usually power stations or infeeds of electrical power is made in a redundant way. So if one of these trips out, the others can easily take over the load. Now let's see what happens and what is the influence of electrical faults to the security of supply. We see here an example, a simple example, which serves as a very good model as a radial network, and we look please what happens to the consumer if a fault occurs downstream from that consumer. The fault has just occurred, you can see it, the color of the arrow has changed to red, and now the protection of this feeder will detect it and will trip out the feeder of the consumer. That means the consumer experiences a loss of supply. If we are not happy with this situation, we should and can take countermeasures by means of additional protection. For example, installing one further protection device, including circuit breaker, downstream of that sensitive consumer. Now let's play the same procedure and the same sequence again. The fault occurs, it is detected by the protection downstream and tripped out, and that means the supply from the source to the consumer is not interrupted. So the consumer has experienced a little voltage dip, but not more. The next case is a fault upstream of that consumer. Again, what happens? The fault occurs, the arrow has changed to red, the protection comes in and trips again. And now it trips the consumer because the fault is upstream of it. Now what can be done if we are not happy with this? And this time, the precautions and countermeasures should be made by the network design. So in this case, we have to install a second line, make the supply more redundant. And now let's see what happens if this fault happens again after this network expansion. The fault occurs and is tripped out by the unit protection of this very feeder. And as you can see here, the electricity comes from the bus bar, goes to the upper healthy line and reaches the consumer. So the consumer is supplied again. The last point that observes attention concerning the relation between protection and power quality is all the faults that are outside of this consumer's feeder. So, for example, in this yellow circle, if a fault occurs here, this fault will be detected by the feeder protection and will be tripped out. And what does that mean to the consumer? First, as long as the grid was all right, we had stable voltage. Then during the fault, the voltage goes down to a few percent of the nominal voltage. And if the fault has been tripped out, there is no fault in the grid anymore. The grid is healthy and the voltage in the grid is healthy again. So that means we experienced a voltage dip, and that was a short dip because usually protection acts very rapidly. So how to measure and how does the regulators take care of these protection functions? That is done by the so-called figure of ASIDI. That means average system interruption duration index. That means more or less a weighted outage time, and the weighting is done by the power that is not supplied. And if you look over to the red square, you see this ASIDI figure is given by the product of the power and the outage time, and that is the energy not supplied. So this ASIDI figure is more or less related to the energy not supplied. What can be done to lower this figure, to improve the quality of supply? That can be done by quick restoration time, by quick fault clearing times, and by very effective remedial switching, either automatically or manually. And in both cases, whoever or whatever restores the supply by switching must have good information about the type of fault, the location of the fault, and that can be optimally received from the protection devices. So the role of the protection devices is to bring the ASIDI figure down to good values, and that is done through good indication and automation. So this was a chapter about the electrical power systems, faults, and the security of supply.